Hello everyone, I am Zainab, your physics educator at Study Room. So, in this video, we are going to start with a new chapter called friction. Now, what is friction exactly? Let's have a look. Now, often these questions must be popping up in your mind. Now, let's see. Have you ever wondered what would happen if you step on a banana peel? Just imagine for a few seconds what would happen if a banana peel is kept on a surface and you step on it. Like how what happens when you ride a bicycle and you apply brakes. It stops eventually. Now why does it stop? What makes it stop? Why is it that your pen can write on a paper but not on a piece of glass? You take a pen and you try to write it on paper. You'll be able to write it easily, as you do always. But you take the same pen and you try to write it on a glass surface. Will you be able to write it? No, obviously no. Now, what do? You slide a ball on a ground surface. It rolls for a certain time and for a certain distance. But what happens then? It stops eventually. Now, why does it happen? Now, all these examples, we saw that there must be certain kind of force which must be acting for all these examples to occur. So, what was common in all these examples? The only common thing was that they all involved a motion of one surface over another. As we saw in the example of ball, as we roll the ball in the surface, there was the ball was in contact with the surface. There were two surfaces involved. Now, definitely, there must be some force acting that determines this motion of the ball between the two surfaces, like the ball and the ground surface, and that force is called friction. Now, this friction, this is a contact force. That is, it acts when there is interaction between two surfaces. That is, that the two surfaces are in contact with one another. Now, we have studied matter before. Let us restrict our imagination to only solid matter and nothing else for now. Now, what do? We perform an activity. We perform an activity for demonstrating and understanding friction. What do? That we take a book, we place it on a table, and we try to push it. Now, firstly, we push it in the right direction, and eventually, we'll observe that the book stops. Now, we do the same activity, we move the book on the left side, and in that direction as well, the book stops. Now we have done in both the direction, as the right direction and the opposite direction. What do we observe then? We observe that in both cases the book stops after a certain distance. That means there must be some opposing force in both the direction that will eventually make the book stop. So, therefore, we can conclude that there must be a force that acts in direction opposite to the direction of books and it stops the book. Suppose if there is a force which is acting in this direction, if we move the book in this direction, this is the applied force. Now, to make the book stop, there must be a force acting in the opposite direction, and this force is called as a force of friction. Correct? Now we demonstrated this activity. In this activity, we can conclude that friction always acts on an object in a direction opposite to the applied force. So this is the applied force and this is the force of friction. So it is always going to act in a direction opposite to the direction of applied force. The applied force is in the right direction, the force of friction will always be in the left direction. Now we have already understood that the friction is a force that acts in the opposite direction to the applied force, and also it acts between two surfaces when they are in contact. But there must be certain kind of factors which must affect this force, which must change this force. So what are these factors which affects these force of friction? Let's have a look. Now let's brainstorm for a certain while. Let's think about some of the things that we observe in our daily lives. Now, the friction acts between two surfaces in contact that we already know. Now, we have already studied matter and we can agree that all surfaces, be it smooth or rough, they have certain kind of irregularities or certain kind of unevenness. Now, suppose we take a sandpaper. The unevenness and the irregularities are clearly visible. If we take a sandpaper, we clearly see that there is certain kind of irregularities on the sandpaper. But if you take a piece of ice, what happens there? If we see with the naked eye, we'll see that there is no kind of unevenness or irregularities. We'll think that there are if a ice cube is taken, there must be no kind of irregularities because the ice cube and the surface of it appears pretty smooth. It appears very smooth. But then too, on such a smooth surface, there are some kind of unevenness and irregularities always present. There must be large number of irregularities in the sandpaper and less number of irregularities in on a piece of ice. But irregularities are always present. There is some kind of unevenness on the surfaces. Now, the different levels of irregularities on different surfaces in contact must be a factor determining the friction. Now, let's do some activities to understand the factors of friction in detail. So, let's perform this experiment. What do? You make an inclined surface on a ground surface. That is, you can pile up the books and then make an inclined surface as shown in the figure. And what do? You take a pen. Now you roll this pen on the inclined surface. And let it roll on the ground as well. Now what do? You take a piece of cloth. You can take a towel or any other cloth, but you make sure that there are no wrinkles or any folds present on that piece of cloth. Now what do? You repeat the same procedure, that is you make the pen move from the inclined surface to the ground surface, that is you make it roll on the towel. Now what will you observe then? Can you think for a while? Yes, you observe that the distance covered by the pencil in both the cases will be different. That is, when you let it roll on a smooth surface without a towel, it will be different, and when you let it roll with the towel, it will be different. That is, we can say that the smoothness of the surface on which the cell moves affects the distance traveled, because the the towel must be having more number of irregularities, that is less smoothness. That's why the distance travel by the pencil will be more, because the surface was smooth in the first case. But in the second case, what will happen, that the towel is more coarse, that is the unevenness increases, and that's why the distance traveled by the pencil, it decreases. That is, the opposing force, that is the force of friction, increases when the experiment is performed with the towel. Now let's move on. Let's answer this question. Now we saw the activity. In this activity, we only change the surface on which the pencil moves. Now what do? Try covering the pencil with a sandpaper which is more coarse. That means it will be having a more force of friction, and we repeat the same experiment. Now compared to the previous case, the distance travel will be more or less. Yes, what will happen, that the distance travel will be decreased. The distance will decrease. Now why does it decrease? Because the sandpaper, it will have more friction and it will oppose at a faster rate. So definitely the distance travel will be less in this case, because the force of friction, it increases when we take a sandpaper and perform the experiment. Simple enough. Against each other. Now what do? We take a mat, suppose we take a yoga mat, and we try to push it without keeping any weights. In the second case, we keep some heavy weights that are acting normally on the mat, and we try to push the mat again. Now what happens in this case? We observe that after putting heavy weight on the mat, that is, there'll be a certain kind of force acting on the mat, which will be normal, which will be a normal force. The force will then increase if we try to move the mat, there will be a more force required to move the mat. Now the same surfaces, now we can conclude that the same surfaces but with higher normal force in between experience more friction. That means if the normal force increases, the friction also increases. In other words, friction force between two surfaces increase as the normal force increases. Very simple to understand, correct? Now we are going to have a look at the types of friction. There are certain types of friction. Let's have a look at this activity. In all the examples and the activities which we saw in the earlier slides, what was happening that we were not considering if the object was at rest or it was in motion. So now let's perform this experiment. We take a box and we try to move it. Now firstly, two forces will be required. First is to get the object, that is to get the box in motion, and second force will be required to keep it in motion. Now apply force to the object and observe the force required in both cases. What will you observe then? Firstly, the box is kept on rest and you try to move it. There is a force required. And when the box is already in motion, again a force is required. So can you think which force will be more? Now we observe that the force required to get the object moving is more than the one required to keep it in motion. The force of friction must be different in two cases. That's what we can conclude, namely when the object is at rest and when it is in motion. So when the object is placed at rest, there will be a higher force of friction required. There will be a higher force required. Now we can conclude that when the object is placed at rest, a higher force is required to move it from rest, and when it's already in motion, a minimal amount of force is required to keep it in motion. Correct? Now let's have a look at what are the types of friction. Now when the object is at rest and when we have to bring it in motion, a friction force that is present between the surface and the object is called static friction. It is known as static friction. Now this is the force that we need to overcome to get the object moving. And when the same object is already in motion with respect to the surface, the force of friction acting on it is called sliding force friction. Now this is the minimum force that we need to apply to keep the object moving. That is, sliding friction will be less than the static friction, because the force required will be more to overcome the static friction and will be less to overcome the sliding friction. Now this was all for this video. We learned about friction, what is the definition of friction, what are the types of friction, what are the factors affecting frictions, and we saw many interesting activities related to the factors affecting the friction to understand friction in a more better way. So this was all for this video. We'll connect next time in the next video to learn more about friction, the advantages and disadvantages of friction. Till then, thank you and see you next time.